Welcome back, everyone. This is The Changelog, and I'm your host, Adam Stacoviak. This is episode 150. Jared and I talked to Zach Supalla, the founder and CEO of Spark. Spark is a complete, open-source, full-stack solution for creating amazing internet-connected things. You may have seen it on Kickstarter. It's fully open-source on GitHub, from hardware to software, and Zach goes deep to school us on everything we need to know. We have 4 awesome sponsors for the show today: CodeShip, App Quality Bundle, TopTal, and DigitalOcean. We'll tell you a bit more about TopTal and DigitalOcean later in the show, but our friends at CodeShip released a new feature called Parallel CI that lets you deploy your code to production 10 times faster than you've been able to do before. If you want faster tests, you have to run your builds in parallel. With Parallel CI, you can now split up your test commands into up to 10 test pipelines. This lets you run your test suite in parallel and drastically reduce the time it takes to run your builds. They integrate with GitHub and Bitbucket. You can deploy to cloud services like Heroku, AWS, and many more. Get started today for free or use our offer code when you upgrade to a paying plan. The Changelog Podcast is the code. Again, the Changelog Podcast. That will get you 20% off any plan you choose for 3 months. Head to codeship.com/thechangelog to get started. And our next sponsor, super awesome to have them come on. It's a time-limited deal, so listen up. App Quality Bundle. It's a time-limited, deeply discounted bundle of web services for building better mobile and desktop apps. This offer expires. It ends on April 15th. So there's little time to buy, but not little time to use. It does not expire. But what do you get? First off, you're going to save 89% on a year of Sentry, RunScope, Code Climate, Circle CI, and Ghost Inspector. When combined together, each of these services give you complete app quality coverage from mobile to web. Here's the best part. What would normally cost you well over $9,000, tons of money. I mean, tons of money for all these services together. You're going to get all of them for $999. That's 1 full year of service of each of those services combined together. That's a huge savings beyond the deeply discounted price. Once you purchase it, like I said, it won't expire. If you're just starting out a new project that needs complete app code quality coverage, this will pay for itself. This is perfect for new projects, projects that are growing up and need end-to-end quality coverage from mobile to web, or for development shops taking care of their clients' services for them. There's only one single caveat to mention, and that it's strictly for new accounts only. There may be some exceptions to the rule, but you'll have to check out the fine print or get in touch with them if you've got specific questions. Check out buildbetter.software. Yeah, you heard me right. Buildbetter.software. And now on to the show. Welcome back, everyone. We got Zach Supalla here with us. Supalla, not Zapala. Zach, I was practicing, and it was the Z in your first name that just had to enunciate the Z in the second name. Founder and CEO of Spark, hardware, cool stuff happening in your space. Jared's on the line as well. Jared, what's up, man?
Excited to be here. Excited to get schooled on some hardware stuff.
Yes. Sure. Well, where do we begin? I mean, let's get started with, I guess, knowing more about you, Zach.
Yeah.
In the pre-call, we talked a little bit about China, the firewall, and GitHub. So it seems like you've got some internationalization behind your belt. What's up?
Yeah. So I started Spark a couple of years back, beginning in 2012. Originally, we were trying to make like consumer products. We were really inspired by Nest and what they're doing with connected thermostats and now smoke detector. And I wanted to do the same thing with lighting. So my dad is deaf, and I really wanted to make his lights flash when my mom texted him. And so, it's like he's got these hardwired systems to flash the lights when someone rings the doorbell, but you can't integrate a cell phone with something like that. So I thought, well, what if I just figured out a way to add a Wi-Fi module to his lights, and then I could create an API and hit that API from, do an API integration with Twilio or something, so that he could get a text message and his lights would flash. And that turned into this whole product that was called the Spark Socket. And this was a consumer product that you could screw into a light bulb socket and screw a light bulb in the other end, and it would bring it online. And I launched that on Kickstarter late 2012 with an unsuccessful Kickstarter campaign. So we were asking for $250,000. We raised $125,000. Kickstarter's all or nothing, so we got nothing. But we had been invited to join an incubator program in China, and so we said, well, whatever, we're going to go to China, we'll figure it out. So early 2013, flew to China with a couple other guys who joined the team since then, and that's when we started. We sort of, over the course of a few months in Shenzhen, decided what was interesting about what we're doing was a lot broader than just lighting. And what if, rather than trying to build our own consumer products, we took the tech that we'd built to make our product work and provide it as a platform, both on the hardware and the software side. And so we relaunched a Kickstarter campaign a few months later for the Spark Core, which was our first Wi-Fi development kit, open source hardware development kit, cloud backend, open source as well. And that Kickstarter campaign was very successful. So that's kind of what put us down the path that we're on now.
Interesting. And one thing we got to say before we get started here is a shout out to member and listener Chris Bechamp, who has been encouraging us to do more hardware shows. In fact, he gave us a long list of ideas. I actually found you guys. I'm not sure how I found you, Zach, but I found Spark. Maybe it was on your Kickstarter. I don't know. And I asked Chris, I'm like, is this interesting to you? And he said, yeah, absolutely. So thanks to Chris for doing that. Cool. We actually have a question from him, which we'll ask a little bit later. But on your homepage, it says Spark is a complete open source, full stack solution for cloud connected devices. As a software guy, that sounds a bit vague. As we get into what you guys offer, it looks like you have the Photon, you have the Electron. What's your guys' core offerings?
Yeah, so it's hard to describe, honestly, because we like the most important thing is for us is full stack. So like we basically want to provide all of the tools that somebody needs to create a connected hardware product. And this is if you're a hobbyist and you're building something on a weekend, or if you're actually a manufacturer and you want to build something in production. But if you think about what you need, so let's say you are a coffee maker company and you want to make a connected coffee maker. Well, so you probably already know how to make coffee makers. So you've got that covered. And you got to get it online. So you got to add some hardware bit that's going to bring it online. So a Wi-Fi module or a cellular module or something like that. So we make those and provide development kits for easy prototyping, Arduino-like development tools, but with a focus on connectivity. And then you need the hardware to talk to something. Hardware, these products they're embedded. They have RAM that's measured in kilobytes. There's no operating system, so it's not like you can just run oftentimes sort of JavaScript or something on there. You have to run C and C++, and you still want to have something abstracted, something easier to work with than just writing this like super low level code. So we provide some firmware libraries, a protocol to communicate to a cloud service. The protocol is very efficient. We're trying to do encryption in a very small memory overhead. And then it hooks up to the cloud, and the cloud, quote unquote cloud, right? Everything's cloud. Is
when you say the cloud, you just mean the internet, or?
Well, we have our own hosted messaging service.
You have your own services that are cloud. Okay.
Yeah, exactly. And the way to I think the best way to think about it is we try to make hardware look like software. So you can make a REST API call and tell a device. You can post to a device's URL /brew. And it'll actually call the brew function in the firmware of the coffee maker. So we've tried to abstract all of the connectivity in the middle, and in order to do that, we have a hosted cloud service that provides the API endpoint, and then the device hooks up to that same cloud service kind of on the other end, on the backside, where you might usually expect a database. Instead, you have hardware. So that's kind of how the platform looks, and so we call it full stack because it's web. We have front end tools, JavaScript libraries, but then it's also firmware and hardware and everything in between.
Interesting. I think one way that helps people kind of understand is to say, what can I possibly do with this Wi-Fi development kit? And honestly, I wasn't sure until you sent me to spark.hackster.io, which is kind of a community site where people have built things on top of your guys' technologies. And I'm just going to go ahead and read a few of these. There's just some hilariously cool stuff here. For instance, the War Kitty.
Oh, that's one of the best.
Which the description there is using the Spark Core GPS and an SD card to turn your cat or dog into a Wi-Fi scanning platform.
Yep.
So it's like going out there looking for Wi-Fi hotspots with your cat. Marty McSleeves is another one. which is a jacket with Back to the Future style variable length sleeves. There's a product called the Foo Bar, which is a Spark powered automated cocktail dispenser.
Yep.
And one last one, the Biff Shocker, which is a DeLorean security system to prevent uninvited drivers. It appears that it like wraps around your steering wheel, and I don't know if it shocks people or what it does. There's some like seriously cool stuff when you just kind of like provide what it seems like you guys are providing, which is a higher level of abstraction on top of, cool connected devices.
Yeah. Well, hardware is hard, and it doesn't have to be. It's that when you're working in that sort of embedded environment and with so many constraints, usually what you're dealing with is like, you're poking at registers, and that makes it really hard to. There's so many layers you have to put in place to solve problems, and I think in the web world we're used to all of these layers being handed to us. These trusted layers of abstraction. You get things like Rails is like very complete framework for solving web problems. You don't have to deal with like TCP sockets, but usually when you're building hardware, you're starting all the way down at the bottom, and that means that it can take months to even get a functional prototype. So that's something we really wanted to try and solve is what can we do to make it as easy to build a connected hardware thing as it is to deploy a Rails site. And that's where, all this stuff we had to build comes into place.
It looks like you started at Wi-Fi, and I believe was that your first Kickstarter was for the Photon?
Actually, for the Spark
Wi-Fi
Core,
kit?
which is sort of the predecessor to the Photon. So we launched the Spark Core in May 2013. We've sold something like 50,000 of those so far. The Photon is its sequel, and that'll be shipping next month. Very similar, just, next generation. So cheaper, faster, better, kind of everything all rolled into one. And then we just recently launched the Electron, which is our cellular development platform.
Which is interesting because for the Electron, you did another Kickstarter. This one, a massive success. I believe it closes by the time the show airs. It will have closed. But over $500,000 pledging. Only a $30,000 goal on that one. So were you once bitten, twice shy, or what was the deal with your goal there?
Well, the Spark Core Kickstarter campaign was a $10,000 goal, so we tripled the goal actually.
Okay.
The last time we raised up more than $500,000 last time too. Yeah. I mean, for us, to be honest, we're going to do this stuff anyway. We've built a community. We've got lots of people building all our tools. We know that people wanted this. Cellular is interesting because it's a whole other set of products. Like stuff that's built with Wi-Fi, it tends to be smart home products, right? So you're thinking about connecting appliances or your aquarium or toys or stuff with pets. But when you get into cellular, it's industrial. You've got people who want to connect sensors on farms and heavy equipment, and so it's a totally different area. And we had a lot of pull, so we knew people wanted it. So we said, well, let's just set a low goal because we know we're going to make this thing.
Yeah, there's some space happening in the on the outside thing. You made me think of a company I know called Skycatch that does drone stuff. Oh, sure. And they're doing drones, and they're flying around. These drones actually have sensors on them, or they're talking to sensors on the ground, pulling back data and sort of pulling that back to a main repository of data and collecting big data for farming and for industrial camps and just all sorts of crazy stuff. Does this potentially tie into those types of, other hardware
absolutely.
options?
I mean, I think that like the Internet of Things is a big buzzword. And I think there's a lot of questions in people's minds is like, well, what exactly does that mean? Right. Do I really need, is the Internet of Things about my Fitbit talking to my microwave? Like, all that stuff sounds gimmicky. But a lot of I think a lot of the applications, we see this very common thread that it's about closing a feedback loop. So like a good example is, let's say you're farming or even gardening, right? And you have an input, which is how moist is the soil, and you have an output, which is like running a sprinkler. And these two things, like, if they're next to each other, like maybe you can have some sort of closed loop that can automate that. But what if you have a big farm and everything's sort of further away and you don't necessarily want to like run a bunch of wires underground? So you need everything to be wireless. Well, these tools make it possible to close that feedback loop so that your input can drive your output. And I think comfort in your home is another example of, well, let's say you have a Nest thermostat, and that's trying to get the temperature right in your home, make you comfortable. save you energy. And you also might have ceiling fans, and they also have a role to play in that. And separately, you might have sensors for, well, what's the temperature and what's it? Obviously, the thermostat knows what the temperature is at the thermostat, but what about in 30 other places in your home? And what if you could also have moisture or motion sensors all over your home that could detect whether you're there or not? So you can sort of take all that pool of knowledge that all these sensors are collecting and use that to drive your radiator or HVAC system, whatever it might be. And those
a much more efficient system could be built around that kind of knowledge.
Yeah, exactly. But a lot of times the people who are building all these products are different. So like what you're trying to do is pull all these things together to close these feedback loops.
Yeah.
I would just hover on Kickstarter for a second, because it seems like there's a trend recently. I think yours would be an interesting perspective to get on it. Mm-hmm. And some criticism that Kickstarter has come under as kind of turning into pre-order starter, where it's not, let's start this new thing that may or may not even be successful. I think Pebble is an interesting other example. Of course, here we have a huge, surplus of money according to the goal. Mm-hmm. What's your take on that? Do you think that's fair? And if so, do you think that's a bad thing for Kickstarter, kind of this change of pace, or a good thing?
I mean, I think that it is fair to some extent. We're a very different company now than we were when we first went on Kickstarter for the first time. Like we, at that point, we didn't know what we were going to become. Now we're a going concern, right? We exist. And so our interaction with Kickstarter and with backers is very different. But I think that it's still what's great is that it still provides an opportunity for people to do things a little differently. So Pebble is obviously they were going to make that watch the time, and they raised $20 million. I mean, it's crazy. But that if they didn't have that platform, they'd be falling way behind Apple and Android Wear. Mm-hmm. So it gives a company like them the ability to actually compete with these behemoths that they're going up against. And for us, the story with the Electron is kind of interesting because, like I said, we knew we were going to make this thing. And when we went into the Kickstarter campaign, we've spent like close to a year probably trying to negotiate telco deals to be able to provide the back end, the SIM cards and the data platform for our cellular product. And this is, you can imagine what it's like to negotiate with carriers. It's not. It's it's long and opaque, and you have no idea what's going on. You don't know who the right people are to talk to. But so we talked to a couple carriers and sort of ongoing relationships, and we found a deal that we were excited about that gave us just U.S. and U.S. Canada to start off with. And then when the Kickstarter campaign went live, we knew this was going to happen. Is that it was very visible, and all of a sudden, every major carrier emailed us within the first month of the campaign. And we were very public about this on the campaign that we have a deal in front of us, but part of why we were going on Kickstarter was to create this visible platform to tell carriers, hey, this is important, pay attention to us. And it worked. And all these carriers came to us, and we were able to work out a deal with Telefonica where we're building with them global MVNO, which is a sort of a virtual carrier that covers 100 countries. And that was only possible because we went on Kickstarter. I don't think we ever would have been able to do that if it weren't for the visibility that we got during the campaign. So, it's definitely, it's different second, third time around, but I think Kickstarter is totally game changing, regardless of what your status is going into it.
On that note, you said this is your second successful Kickstarter, and Jared, kind of teased you about having a $30,000 goal, but going to $500,000 in actual, I don't know, funding starting. I don't know what you call that.
Pledges.
Pledges. So I guess for someone who's done it successfully, do you go back because that's a good place to go, or you don't mind giving them the 25 or 30% that it is, or what's the percentage? Like 10%?
No, it's actually less. It's just 5%.
5%.
Yeah.
Okay, so you don't mind giving up 5% to go back to the Kickstarter model and reuse that platform.
Right. They're the Kickstarter. The people who are on Kickstarter are a unique set.
They get it.
They're really engaged. They're the best customers you could have because they're really, really engaged. They really want you to be successful. They invest in you, especially as an open source project. They're people who want to participate and want to be involved and want to provide feedback. And if you treat them poorly, they're an angry mob because they're so engaged, right? If you don't give them an outlet for that, and you're just silent, and they'll come after you. But if you're good at managing them, then it's an amazing set of customers to have. And so that's really powerful. Kickstarter, like the people who work at Kickstarter, we've gotten to know their team well. They're awesome. They really just want to help people do new things, and they're really, really excited when people are trying to do something different. They love open source stuff. Anything open source, they just get way behind because they see it as their mission is to empower people to do new things, and that's what open source is about, right? So I think everything about the experience is just it's phenomenal for us. Like we just love working with them.
Well, now that we're on the note of open source, let's take a quick break. We got to hear a word from an awesome sponsor that makes this show possible. But when we come back, we're going to talk about open source. So give us a second. We'll be right back. I want to share a more personal note today with you about our awesome sponsor, TopTal. You've heard us talk about TopTal several times. For long-time listeners, you know that TopTal has been supporting the show for the better part of a year to a year and a half now. If you want to go to their website while I'm talking here, it's TopTal.com. It's one of the best places to work as a freelance software developer. We've been working with TopTal, like I said, for about a year and a half now. And over this year and a half, I've gotten to know their co-founder, Brendan, very, very well. I love what they're doing for the software development community. They care deeply about software developers having awesome engagements to work on. And they also care about awesome engagements, having really awesome software engineers to work with them. So they really make the marriage between a business with great opportunities and an engineer needing great opportunities to work on. They make that marriage possible. Well, we took our relationship to the next level and went there ourselves. We're building something very cool behind the scenes here at the Changelog to power the future of what we're becoming. You're going to love what we're doing. We hired a software engineer through TopTal. His name's Rafael. So if you're a member and you're in the members only Slack room, say hi to Rafael. He's in there. But I wanted to tell you just how deeply we care about our relationship with TopTal and how much we trust who they are. And if you're freelancing right now as a software developer and you're looking for a way to work with top clients, maybe even us, on projects that are interesting to you, challenging, and using the technologies you want to use, I will go as far to say that TopTal is the place for you. Head to TopTal.com/developers. That's TopTal.com/developers to learn more and tell them the Changelog sent you. All right, Zach, we're back. Let's talk about open source. I know we got several open topics that we can sort of go down when it comes to open source. But I guess the first question would be, why open source? Which you kind of teased on, but in what way are you engaging open source?
Yeah, it's a good question. So, open source for us is we're building a business. We hope to build a viable business and profit as a company, and so. Building open source businesses is challenging because in a lot of ways you're giving away a lot of what you do. So the question is, well, how do you build a viable business that way? And for us, the reason that we're open source is because what we're trying to do is build a platform for other people to build products on top of it. I think a lot of those people are very wary of platforms like us because they're worried that we are trying to take all of the value that the products might generate, right? That if you have someone who makes hardware and they sort of feel like commoditized, right? Like they're just one thing of many on the shelf and they're trying to escape that by building connected products. That if we come in and we say, well, we're keeping all the data, like everything you learn is ours and all the money that you make is coming to us, then I think people are worried about that. They're worried about an iTunes kind of thing where Apple sort of collects a lot of the value that used to be distributed to other companies in the music industry. And they're very cautious of that. For us, open source is a way for us to say, look, we're really not here to screw you over. Like we're actually just trying to help and provide a valuable infrastructure. And we hope to be paid for the work that we do.
It's a good value statement there. We're not trying to screw you over.
Right. Yeah, exactly. And the way that we prove that is by saying it's open source. And basically we say, well, look, there's a lot of what we do is open source. Our hardware is open source. Our firmware is open source. The basic functionality of the cloud platform is open source. Our SDKs and our IDE and everything, they're all open source. And there are parts of our platform that are closed source, that are proprietary, higher level parts, sort of like, GitHub versus Git, like the tools that you use to oversee and manage your connected products. Those tools are proprietary. And our thought is, well, if we're doing a good job with those tools, then you'll stick around, you'll pay us money and for the services that we're providing, and we'll build a viable business. And if not, then you can take our open source stuff and go. You can leave at any time. And that means that we're only there if we're valuable. We don't create any lock-in. We're not, we don't force you to stick around if we're not providing value in the long term. So for us, it's a way to keep ourselves on our toes. It's a way to mitigate risk for our customers, startup risk too. Like, what happens if we exit, we get acquired or we go out of business, we're a startup. So, being open source, I think helps solve a lot of those problems. And so, yeah, it's very important to us. Open source hardware is relatively young compared to software. It's still something that's being figured out.
On that hardware front, when you share the hardware piece of open source, what does that look like? Like when you build a software program, it makes sense that you see JavaScript or a particular language, or Eagle.
Eagle, man. My Eagle question. What's Eagle?
Eagle.
On your guys'
Eagle
on Spark Core's, let me just set that up a little bit.
Yeah.
On Spark Core's GitHub page, you check out what's on there in the repo, and the language is 99.8% Eagle, which is the first time I've ever even heard that in the context of anything open source. So with that being said, go ahead.
So hardware and open source is really interesting. It's totally different because software, the whole premise behind the reason that you can open source software is because software is managed under the same IP laws as novels, right? Copyright. It's copyrighted, and so you can provide a license to use your copyright, and that's what every open source license is. Hardware is different. Hardware is not. You can't copyright hardware. You can patent hardware. It's treated under a different set of laws. So it's funny because like when we say open source hardware, what we're basically saying is, well, we make hardware designs like circuit designs, and we give them away and we allow people to use them however they want. The funny thing about hardware is that's true so long as you don't patent it. That's always true. Like if I give you a circuit board and you take an X-ray and you look at it and you reverse engineer it and like build the same circuit, like that's legal. So for us, it's almost more of a statement than anything else. It's like we really want people to feel free to use these design files if they so choose. Eagle is CAD software, so computer aided design. So if you want to design a circuit board and basically like draw all the little copper traces that are going to connect this bit to that bit, there's a bunch of software tools out there that you can use. Most of them are really expensive, $5,000 plus. CAD software is not cheap. And Eagle is one where it's not open source, but it is free to use for sort of smaller projects and non-commercial projects. So it means that we can give people these tools and say, well, you can go download Eagle and you have access to it. You don't have to go buy a $5,000 program to open our design files. And Eagle has become sort of the de facto standard for open source hardware. So when Arduino and companies like that deliver their hardware design files on GitHub, they typically use Eagle.
I'm just excited that I guessed it right. You think I would just go Google it and figure it out, but I didn't. I was like, I bet that's CAD stuff, and I just got that's as close as I got to figuring that out. So,
well, I'm glad it says Eagle now because like it's funny actually. The last time I checked, GitHub didn't know what Eagle was, and so it said that if you looked at my GitHub page like a year or two ago, it said that I was like a Prolog developer. I was like, what? I am not a Prolog developer, but it's because I think the file type or something of the Eagle files was like very similar to the Prolog one, so it just thought everything Eagle was Prolog. So I'm glad that they've added Eagle as a language.
You don't want to be a Prolog developer? Come on.
I mean, if somebody asked me a Prolog question, I would be lost.
Well, now you know how I feel about Eagle. So Spark Core out there, open source. It's not the only thing you have out there. You guys got a lot of repos.
Yeah.
The firmware itself, I assume that's firmware for the Spark Core.
Yeah.
That's in C++. And then you do kind of hop higher up pretty quickly. You have Spark.js. Maybe we can take these in order. You got Spark.js, Spark CLI, Spark Dev, And these are all kind of in JavaScripty, CoffeeScripty languages. So maybe tell us about Spark.js.
Yeah. So basically, like when you build a connected product, you're often building a couple things. You're building the hardware, and then you're building the app to interact with the hardware. And the cloud acts as a gateway in between. So the app, it might be a mobile app, might be a web app, whatever. We started with JavaScript because, JavaScript's pretty popular. So Spark.js lets you write an application that interacts with your hardware either from on the server side using Node or in a browser. And so it makes it easy to interact with the hardware without digging in too deep. Also, it's all going through this REST API. So it's sort of a wrapper for the REST API to interact with the hardware. And then the same concepts are baked into the command line interface, which is our CLI. So you can use the CLI to like sort of poke at the hardware and ask it questions and call functions, monitor data coming off of the device and yeah.
So you have this JS library to talk to Spark Core, and it says Spark Cloud. So it seems like both interfaces. What does Spark Cloud add? I'm assuming that's your proprietary side. Maybe you can talk about if that costs extra or how you do, all that stuff. But what Spark Cloud add feature-wise? Right.
So actually, there's an open source. Spark Server is the open source implementation of our cloud platform. But basically, there's a few things that are challenging about talking to hardware directly. One is that often the hardware is it's on a local network. So let's say you have a thing at home and you're at work and you want to preheat your oven, your connected oven, right? So it's on your home network. So now you're talking about doing NAT traversals, dealing with firewalls, right? All this nasty stuff that you really don't want to deal with. The device, the hardware holds open a long connection, a TCP socket to the cloud. And that means that it's always available. So you can communicate with it from anywhere. Another thing that's really hard on the hardware is authentication. So like I want to basically say, well, I want to be able to talk to my oven. I want to be able to tell my oven to preheat, but I don't want anyone else to be able to tell my oven to preheat because that would be a fire hazard, among other things, right? A lot of issues there. Mm-hmm. And I might not even want people on my Wi-Fi network, right? Like if I tell my friends they have access my Wi-Fi password, should they have access to it? What about my kids? Like if they download an app, should they have access to it? So we can, by using the cloud as a gateway, we can put in place authentication that you wouldn't be able to do on the hardware. So we use OAuth you can log in and have access and an access token that you can use for API calls, but also you can integrate with third-party services. So you could provide access to somebody else, to an app that could interact with your hardware thing. And so like you could never do that just on the hardware. That you need the cloud platform to sort of stand in the middle. And so those are the reasons that people, there's value in a cloud platform. And also
that makes a lot of sense because I mean you bake all that smartness into the cloud,
right?
Into your cloud, user authentication, things like that, and interoperability. We use Slack a lot, so it's easy to think about integrations and stuff like that. So it's easy to sort of pull in other web platforms or other web clouds.
Yeah, exactly.
To sort of add on without really having to do much and just provide access to this open source API like you've done.
Right. Exactly. And it makes it much easier to integrate with other web services and also like encryption and like you have so little memory on this thing. It's hard to do sort of full implementation of like web protocols. So instead we use a protocol called COAP, Constrained Application Protocol. It's like a super byte efficient version of HTTP that's designed for hardware, for embedded systems. And so we use that to talk to the cloud, and then the cloud can do HTTPS. So the stuff that's a little bit heavier, that requires more overhead, you don't have to do from the hardware directly. And we can also do stuff like you can send code, you can send a code snippet to the cloud through the API, and we have a compile service that will compile that code into a binary that can then be dropped over the air onto the hardware. So you can reprogram your hardware wirelessly.
That's amazing.
And the compile service is what makes that possible. So like stuff like that you couldn't do without something in the middle. So and then again it's open source, so we're not trying to like be the ecosystem, right? We're trying to open it up. So so you can use our proprietary one, and then our platform, there's some differences between ours and the open source one. Ours has a bunch of scaling infrastructure in place so that we can do like really, really large deployments. Whereas the open source platform is really just a single JavaScript application. So it can handle as much traffic as the application can, as your system can. So our proprietary platform scales better. But yeah, that's pretty much what the cloud does.
You mentioned authorization, and getting a little timely here. I'm sure you saw Amazon Dash button launch today. We'll talk about the Internet of Things. Here we have a new thing from Amazon, which is basically a button that is locked, it seems like, to a specific vendor or a specific product, and you stick it on some device. I think their canonical example is your dishwasher, or excuse me, your laundry machine.
Right.
And you got your Tide button there, basically. And when you're getting low on Tide, instead of having to do whatever it is you previously had to do, now you just hit your Tide button, and it fires off a purchase order to Amazon, and it magically shows up at your door.
Right.
Authorization, I think, is an issue with the Tide button. As I have 4 kids. I don't know about you, but that would be their favorite button in the world, I'm sure. Right. But that's the
Jared
kind of
goes broke by buying too much Tide.
Yeah, just a huge, a pallet shows up one day. So authorization, an interesting thing. But
Tide.
Is this the kind of thing that you could easily build on top of Spark?
Yeah, absolutely. And it's actually a great example of closing the feedback loop, right? And I think that when it's a button, you still have a human element, right? And which creates, in some ways, it makes it easier because you can just tap the button, but it also creates problems because like your kids can tap the button. Right. Whereas I think the end goal is like anything that has a consumable element should be able to recognize when it's running out of the consumable and reorder it, right? So like, like dishwashers, great, and laundry machines, great, and they or what about oil for your car or anything that uses oil, right? Or food. If and this is like the connected fridge is always just like people get really annoyed at it because they make these connected fridges and they're really just like iPads duct taped to the front of a fridge.
Yes,
like it's not really a connected fridge, right? But what if you actually did a connected fridge right, which is like it had a camera in it and it can sense what's in there and how long it's been in there, and it could reorder stuff when like it knows that your milk's been in there for like 4 weeks and it's full, but it's definitely expired. So it could reorder your new milk, or maybe if you're not drinking your milk, you shouldn't reorder milk. But
right.
Like it's very often the same story of like closing the feedback loop. And consumables are a huge part of it. I think what Amazon's doing is really smart. And actually, in addition to the button, they opened up an API so that you can use their reordering system without the button. So we looked at that and we're like, we totally have to integrate that into our web service, because what if our customers want to build products that can hit this API to reorder the consumable from Amazon? So that's like we're super jazzed about that.
Yeah, instead of everybody having to do it themselves, you could do it once, and then your customers could all just use that.
Exactly.
Yeah, I just remember, I don't know what episode, Adam, do we have Chris McCord on with Elixir? I was just...
148.
Yeah, 148. I was just speaking skeptically of the Internet of Things and kind of noting how it's all very kind of novelty and vague, and there's not like real value propositions yet. But I think it's just a matter of time. I mean, even just when I saw the Amazon button, I was just like, okay, that's actually a really good use,
Right.
And you start to be like, okay, soon we're going to start to see things where we're like, wow, that's life-changing in a very small way, right? And I think you're right on par with the closing the feedback loop. And that's why things like Spark are exciting, because you don't have to be Amazon to put something together anymore.
Exactly.
You have these open source options, and you have these small, cheap entry ways to building stuff, which is why I think this Hackster site is so cool, because here you have people just basically having fun and building things that I would have never imagined, just because with the capabilities.
Well, and that's where I think like the hardware world still has a lot to learn from the web world, where like, if you're building web tools or web software, the tools that you use in a production environment are the same tools that you use as an individual, like building a hobby weekend project, right? So like it's the same programming languages, it's the same frameworks, right? It's not like there's some like set of tools that are hidden to you as an amateur. And in the hardware world, there's still generally a pretty big gap between the professional tools and the and sort of the hobbyist tools. So like you've got kind of Arduino and Raspberry Pi for these hobbyist projects, and then professionals are using like, you know, like an IDE like Keel. It costs like 10 grand, and you know, they're using a different set of microcontrollers. They're purchasing components from like Qualcomm and Broadcom, who won't sell them. They will not sell you anything if you're not buying 1 million units, right? So like you don't have access to them as an individual. And so there's this rift in tooling between professionals and amateurs. And that's one of the problems that we're trying to solve, is say, well, look, if we could take the best stuff that the professionals have, give access to everybody, then it could close the gap, and the world would start to look a little bit more like the web, where I think it's fascinating in hardware. You have the concept of a hobbyist, right? Like, what about a hobbyist software developer? Like, well, you don't really have a hobbyist software developer because they're just software developers on weekends, right? It's the same people as the professionals. And I think that's kind of true of the hardware world too. There's a perception that you have these two different groups, hobbyists and professionals, but I think that they're mostly the same people. It's just whether you're talking to them on Saturday or on Tuesday.
Good point. Let's loop back to some more open source projects you guys have here.
Yeah.
Spark Dev, which you term as a professional hackable IDE for Spark, based on GitHub's Atom.
Yeah.
Interestingly, Facebook just released Nuclide or Nuclide EE.
Yeah.
I don't know how they pronounce that, but it's a unified IDE for React and React Native based on GitHub's Atom. And so it seems like you guys beat them to the punch on this. Tell us about it.
Yeah. So like so when we launched the Spark Core, we had a web IDE, which people could use, which is great because you don't have to have a tool chain or anything installed locally. You can just like go to a website, write some code, hit the flash button, and it reprograms it wirelessly. Super awesome for getting started. But it's hard to build a web IDE that's as sort of complete and as comprehensive as a professional would want. And so we'd been looking for a while to figure out, like, well, we want to do something that you can download on your local machine and really have like a professional experience with. And, you know, when people are doing embedded code, usually the common tools are like the expensive proprietary IDEs or like Eclipse. And Eclipse is great, and it solves a lot of problems, but it's cumbersome, and there's a big rift, but there's a big gap between Eclipse, I think, and like, you know, the simpler tools. And so when Atom came out, we thought, oh, this is perfect. This is a great platform for us to use. GitHub is clearly investing a lot in making this thing awesome. They've done so much development on it, and it's evolved so quickly. And it's also web connected, so we could do stuff like hit our cloud APIs from the same IDE, where you can also like, you know, deploy firmware locally using a local toolchain. So we took Atom and sort of added a couple layers of specifically for our hardware to turn it into a standalone IDE, which I don't know if that was what GitHub was intending that people would do with Atom, but it's really well suited for it. And so I think we were the first people to do it. And then when Facebook, I mean, I was not surprised to see Facebook do something like that, because it's, you know, it felt somewhat obvious to us, like somebody else needs to be using it in the same way. But yeah, they've built a pretty great tool there. I like it a lot.
Question for me, I guess, on this note is, when we look at Atom or we look at Sublime Text or other text editors out there, why fork Atom, create your own version that sort of adds, you know, ability specifically for your infrastructure? Why do that versus sort of a plugin or a bundle as TextMate does or Sublime Text? Why go and actually create the own IDE? What's the value add there for Facebook or for you?
Well, that's a good question. And here's the trick. Really, we just did create a plugin. So like, actually, you can just go install the Spark Core plugin in Atom, and you end up with the same thing. But for a lot of our customers, like, you know, our customers aren't typically web folks. Like, we have a lot. I shouldn't say that. There are a ton of web developers who use Spark, but I would say the majority of our customers are like more of sort of embedded developers, and they come from a different place and are used to a different set of tools. So GitHub is not necessarily a brand name that they recognize. It's just a little bit of a different world. So, you know, for us to say, well, go download this Atom thing and then install this, it feels like, wait, whose website am I going to? I don't trust these GitHub people. Right. And of course we think that's silly, but whatever. So we package it up and say, look, here's a downloadable thing. It's just it's an application that you can download and double click on it, it'll work. But if you are, if you're familiar with Atom, you can just install the plugin and it'll work the same.
That's cool.
Yeah.
I'm looking here. I'm looking for the Atom license, but I'm assuming it's pretty liberally licensed. I think that's some of the value of open source. It's okay. You can take that. You can put your name on it as long as it adheres to their license and their copyright and all that. Yeah. And you can make your company. It bolsters your company. Yeah. And to your customers who may or may not be interested in Atom, here it is. It's Spark Dev. It's all included, and then you can you don't have to just maintain a little plugin and fit inside of that box. If you have more kind of deep ingrained things that you want to change, you can go ahead and do that.
Yeah, exactly. Cool. And we didn't, we weren't sure because we did it pretty early in Atom's life, so we didn't know how GitHub felt about. We didn't know what really they wanted to do with Atom, so we had a couple friends there, and we were like, "Hey, so we're building this IDE with Atom. Like, is that cool? Like, I know it's open source, but like, we don't want to, we don't want to piss anybody off." And they were great. They loved it. They were like, "Oh yeah, that's great. It's awesome. Go for it." So I love it.
I don't know if you found it, Jared, or not, but it's under the MIT license. And when they announced it, they actually said Atom, free and open source for everyone. So I guess the MIT license does afford you the ability to fork it, kind of repackage it. And so long as you're not doing things that are against the MIT license, you're good to go.
Yeah.
Right. Yeah, exactly. Well, this is probably a good place to pause and hear a word from our sponsor. When we get back, I want to talk to you about getting into the hardware scene as a web developer, as a software developer, and get some tips from you. But we'll be right back.
Sure.
Over 400,000 developers have deployed to DigitalOcean's cloud. DigitalOcean is simple cloud hosting built for developers. In 55 seconds, you'll have full root access to a cloud server, and it just doesn't get any easier than that. Pricing plans start out affordably at $5 a month for half a gig of RAM, 20 gigs of SSD drive space, 1 CPU, and 1 terabyte of transfer. All DigitalOcean servers run on blazing fast SSDs with tier 1 bandwidth and come with private networking. Use the promo code ChangeLogApril to get a $10 hosting credit when you sign up. Again, ChangeLogApril, $10 when you sign up. New accounts only. Head to DigitalOcean.com to get started. And now back to the show.
All right, we're back. Zach, I'm a web developer. Adam's a web developer. A lot of our listeners are web developers. Of course, we do have the Chris B. Champs in the audience who are probably sitting there wishing we're asking more hardware-y, hackery questions. But we just don't have that in our arsenal right now. If I'm interested, maybe in Spark, maybe just in like making my own thing, what's a break-in point? How do I get involved in open source hardware?
Yeah, great question. So, I think that the best way to get into hardware is by having something that you want to build, right? Like having an example, a project in mind, because I think you learn better. You learn a new area better if you have some intent, right? It's more important to you. So like when I started, the first thing I built was I had a little garden, and I was trying to make it use an Arduino, which is so an Arduino is a platform very similar to ours, but it's just a microcontroller. So it's really just the brain and not the connectivity. You can get shields, accessories that bring it online. But so I got an Arduino, and I built a little moisture sensor for my little garden. And had it connected to a pump and was trying to pump the water when it got dry. Actually, I never got that to work, but it was right. Let's be honest. But having some project like that, and then I think that like a lot of the concepts, platforms like ours. So I think Spark is a great tool for web developers because we've tried to abstract everything, so you don't have to go sort of too deep. There's definitely some level of knowledge you have to pick up along the way of circuit design. But I think one of the things that's important to know, and it's like, you almost don't know this if nobody tells you, it's really hard to hurt yourself with hardware. So like, I think a lot of people are a little nervous because they're going to like electrocute themselves. Like this stuff is all super low voltage. Unless you're plugging into the wall, it's basically impossible to hurt yourself. And the worst thing that you're going to do is there's a term of art in the hardware world called letting out the magic smoke, which basically is like, you have a chip that is expecting 3.3 volts and you give it 10 and you see this little, right? And then like this little black smoke comes out of it and you're like, oh, I just destroyed that. But like if it's, it's like, So that you don't do that.
The sound effect was awesome too. I like that.
It does make that sound. And it's like, well, that's okay as long as your hardware is cheap, right? Like if the Photon's $20. So I would typically say, especially to someone who doesn't have any hardware background, buy two, because you'll probably let the magic smoke out of one of them.
Consummate salesman.
Yeah.
Go for the upsell. Buy two.
Yeah, buy two. But it's cheap, so it's not that big of a deal. And if you put something in backwards and whatever happens, it's fine. You just buy a couple of everything, so you have extras, and you have to learn some basic concepts of adding resistors so that you can limit current to things. Is some sort of basic stuff like that. But a lot of it's available online. YouTube's your friend. There's websites SparkFun and Adafruit are both retailers that sell DIY kind of hobbyist electronics. And they've got tons of tutorials that walk you through stuff. If you Google anything sort of plus Arduino, you'll get great tutorials on how to do something. So if you Google, for instance, moisture sensor Arduino, you'll find an unbelievable wealth of knowledge. And our platform is Arduino compatible, so that all the code, basically everything that you do in Arduino works exactly the same on Spark. So all of that stuff will work, but then with our platform, you can also bring it online if you want to add sort of web stuff to it. So I think that the best thing to do is buy a dev kit, like a Spark Core, a Photon, or if you're doing embedded stuff in Arduino, if you're doing stuff that you need to be online. Or a kit where a lot of the companies like SparkFun and Adafruit have these kits that have the dev board and other stuff. So a bunch of jumper wires and a bunch of extra sensors and actuators, little motors and stuff, so that you have everything you need in the box to get started. So those are really great. SparkFun has one called the SparkFun Inventors Kit. That's really what I started with. It's awesome. We sell something called the Spark Maker Kit, which is very similar, same kinds of things, but again, designed for something that's connected. And so that stuff is great for getting started, and then you can go buy more components online, or I was about to say Radio Shack, but actually I guess that's not true anymore.
Yeah, don't do that.
That face.
But online, you can still get it. And yeah, it's just, find a project, get started, Google around. Same learning process as learning a new programming language, I think. But, I think to anyone who's done software development, a lot of this stuff, it'll come naturally because it's mostly the same concepts. It's just a little bit lower level.
I think I'm kind of inspired by this spark.hackster.io site, because the stuff on here is so freaking cool. What I picture of myself getting into hardware, I imagine, the first couple of weeks or the first month, it's I get this little LED light to go back between, yellow and red. And to me, that just does that doesn't really do it for me. I don't want to invest time and money and, frustration into a LED light going, yellow and red.
Right.
But if I can see some end goals like this, and maybe these are way outside my league or something, but it seems like there's just some really cool, actual useful things, and some just silly, War Kitty.
Yeah.
That might be within the realm of possibility nowadays for a starter.
Oh, totally. So I'll give you one actually that's a really good starter project, which is one that we did at the end of last year. So when the last Hobbit movie came out, we were inspired to create, and actually this was also inspired by War Kitty, which is one of our favorite community projects. So we built something called War Sting, and so I assume you guys are familiar with The Hobbit and Lord of the Rings.
Of course,
of
course.
Oh yes,
the sword Sting that turns blue when there's orcs nearby.
Mm-hmm.
So. They sell you can buy on Amazon or wherever these $30 toy swords that turn blue. They have a little blue LED in them that you can flip a switch and then it makes hacking and slashing noises. So we bought one of these and we opened it up and realized that the circuit's really simple, and there was room for a Spark Core inside the hilt of the sword. So we published a project. So if you go to our blog, which is blog.spark.io, and scroll down a bit, you'll find instructions for building your own War Sting. So this is a Hobbit sword that will turn blue near any unsecured Wi-Fi network. And if you swing the sword, it will hop on the network and publish a message that says this network has been vanquished. And
where
that project,
will it publish it to?
Publishes, we have an event stream that comes out of our cloud. So it's available globally through the cloud as a public message. But so and then you could very easily, you could do a webhook. We have this really simple webhook command using our CLI. So you could pipe that over to like, someone else's API, like Twitter or Twilio or whatever. But it's like, it's a cool project, and it's really easy because all you do is you like literally snip a wire in the hilt, and then like solder. You do have to use a soldering iron, but it's a good learning experience. You solder.
I'm out. You lost me.
Yeah, me too.
You solder the wire to like two of the pins on the Spark core, and then you copy paste the code, and like put it in the web IDE and flash it over the air, and now you've got this connected sword.
Nice. New talents.
Yeah.
That sounds so awesome.
That sounds so awesome. Yeah, the soldering part does a little lose me because I have a hard time plugging USB cords.
Yeah,
so.
I got these fat fingers.
Who doesn't, right? Try it twice.
We'll link this up in the show notes, by the way. I'm looking at this blog post right now, and I'm thinking, my kids would think I was so cool with this thing.
Oh, yeah.
My wife, not so much, but my kids... They would love it, right?
Yeah. So we actually we were super excited about this because we were, it was totally like a gag, right? A stunt that we were just like, maybe we'll get some attention online. And we posted it and no love. Like the first 3 days, like, like 1,000 people saw the blog post and were like, oh, this sucks. And then like a week later, it got put up on Reddit, and it got up to number 26 on Reddit, which is the one away from the front page. So I'm like so close. But now I think the YouTube video's got like something like 300,000 views. So a lot of people have checked out our very ridiculous. Also, the YouTube video is like silly. One of the guys on the team is dressed up like Gandalf, and another one's dressed up like Frodo. It's or Bilbo, I guess. So it's silly, but it's fun.
Well, let's switch gears here and let's ask a question from Chris himself, the requester of the show and a hardware guy, Chris B. Champ, who told me that what an interesting conversation would be, and this will probably be a one-sided conversation because I got nothing to bring to it, but I'm going to ask it and you can speak to it, all right?
All right.
All right. He says, what would be interesting is the process that they, meaning you guys, and other board makers follow to get their boards manufactured and to market. He says, something tells me that they're not fulfilling orders by soldering surface mounts all day in their garage. Can you speak to that?
So we did start in a garage, like making them by hand. I'm very proud because when we did our first, so basically, I'll go through the process. So circuit boards are, in some ways, it's a little challenging to figure out how they're made, but there's a million places that do it, right? There's a lot of expertise out there. So in a lot of ways, you're just kind of finding a factory and letting them solve a lot of the problems. But basically, the way that it works is when you design a board that you're going to use in a mass manufactured product, you use Eagle to design the board and sort of find all of the components that you need, the sensors and the microcontroller, everything like that. You lay them out on the board, and the layout on the board is like, it's an optimization problem. It's like, what's the smallest surface area that I can get all of these things on and also draw little copper lines between each of them and not have any of the copper lines cross. So it's just a good old fashioned engineering problem. So you lay out the board. You usually takes a couple iterations to get something that you like. And then you send them to PCB manufacturers, printed circuit board manufacturers. So these are the guys who actually give you the circuit board. And in the US, it can cost a lot of money. The best for prototyping, there's a company called OshPark, OSH, it's open source hardware, oshpark.com, I think is their website. And they make these purple boards that have become very well known. You see a purple board, you know exactly where it came from. But you can send them a design file, and you export from Eagle in something called a Gerber file. So a Gerber file is like the output that all of these PCB manufacturers know how to speak. So you send them a Gerber file, and then depending on how much money you pay and who you use, like sometime between 2 days and 3 weeks later, a circuit board arrives. And now, so you buy the components. You go somewhere like DigiKey is a common one, or Mauser. There's companies that sell all these components. And then if you're overseas, you use someone else, and they'll send you the components. You take solder paste. So in low volume, what you do is you take solder paste, which is like a liquid form of solder, and you put little drops of it on all of the pads on your board, and then you take a pair of tweezers and you put all the components on the pads and you put it in an oven. And there's particular ovens that you use for this that are called reflow ovens, that are designed to make the solder paste flow. But actually, you can use there's tons of stuff online about how you can use a convection, like a little toaster oven, or a little frying pan to do this. So you can do it with anything. You don't need fancy equipment. And then that's like how you design it in low volume. When you go high volume, you go to a manufacturer. So you find some manufacturing partner. The places that do this are called PCBA, so printed circuit board assembly. And typically they will then order the circuit boards for you, and they'll order the components for you. So they get all the inventory. And then they have machines that are called pick and place machines that are basically like, us using tweezers except on steroids. So they have these little arms, robotic arms that will take these little tiny components, like less than a millimeter squared, and pick it up with a little vacuum and drop it on the thing. And they can do thousands of components per minute, super fast, unbelievably fast. And then it'll be this sort of conveyor belt that brings something down through the oven, or sort of through the pick and place machine, and then into the oven, and then it comes out baked and ready. And then you program them. So you'll have a programmer, which is usually just a PC with a port that you can hook up to this thing and program the board, the microcontroller, with your software. And usually these will be done in panels. So you'd have 10 boards on a panel. And so somebody will snap all of them off and then put it in a box or a bag or whatever. And that's the process. So, to go through all this and figure it out, a lot of it is finding the right partner, and, finding a manufacturing partner who's willing to work with a startup, getting them on board, going through these iterations with them. There's a lot of work that's called DFM, which is designed for manufacture. So optimizing things so that they're more manufacturable. And a lot of times that's make sure to label which direction the LED is supposed to be pointing so that somebody doesn't actually accidentally put it on backwards, or make these two components further apart so they don't accidentally bump into each other. So it's in comparison to software development, I think one of the things that makes running a hardware startup hard is that you can't just do it can't be two guys in a garage, can't build a $1 billion business in the same way that you can with software. You have to partner with other people. It's messy, it's dirty. It's not like software. You write the right software, it works. Manufacturing, even if you design the circuit board right, you still have yield. 1% of your boards aren't going to work for some reason that has to do with the physical world and all of its imperfections. And so you have to test everything, because you have to throw that 1% away. You don't want to ship that to a customer. So it's way messier than software. But in the end, it's engineering. A lot of the same concepts apply, and it's hard, but it's rewarding. And the fact that it's hard means that fewer people are doing it. So it's not like software development where if you're making a mobile app, there's probably 20 other people making the same mobile app that you're going to be competing with. Hardware, you do something cool, probably nobody else is doing it, and Engadget will probably write about it because there's just not that many things.
Yeah, they need more and more content on that side for sure.
Yeah,
because there's just not. It's a smaller market,
right? Yeah, exactly.
There's less people willing to do that.
Right. It's messy, and that's a nice barrier around your business. You figure it out, and you figure out how to make something, and then that it's not like somebody can just come rip you off, because it's actually pretty hard to do this stuff.
Well, one way to be successful is to do something that no one else is willing to do.
Right.
Right.
Yeah.
That's how you get there.
Yeah.
Because if I'm willing to do it and you're not, guess what? I win.
Right.
That's how you're winning.
Exactly.
That was a nice crash course into the hardware side of this. It seems like we could probably have an entire other show on just that with you, schooling us on all facets of the hardware side of it. Because, like you said, there's a huge barrier there because no one's really willing to do that hard work.
Yeah.
I'm not saying no one, but it's less enticing.
Right.
So it's less easy to. There's a lot more moving parts and a lot more fail, and even costs.
Right. So we actually just recently launched a blog because we're trying to explain all this stuff so that more people can do it. And so we launched a blog a couple weeks ago. It's called Prototype to Production. So the website is proto to prod, PROTO to PROD.com.
Number two or spelled out?
Number two. Yeah. So, and the goal with Proto to Prod is like to answer all these questions and to show people the path that they can follow and teach each of these steps. Like our head of supply chain, Will, wrote a blog post on like selecting your bill of materials and like finding all these components. And it's a massive blog post, but he's an incredible writer. And so it's, I think, actually pretty easy to follow. Like you can read it and you come out of it and you're like, oh, I get that now. Like that sounds like totally crazy and like, like so far from anything you've done before. And you read the blog post and you're like, oh, this makes sense. So we're trying to, we've got a couple posts up now, but over the next couple months, we're trying to tell that whole story of like literally, from a single prototype to making 100,000 products.
Well, Zach, we would love to keep you on the line for much longer, but our listeners tend to be commuters, so they love commuter-friendly shows, tend to be around an hour or a few minutes after, but we have a few awesome closing questions we love to ask that sort of let us know a bit more about who you are. So the first question that we like to ask is, who's your programming hero?
So,
or even your hardware hero, I guess, in this case for you.
Oh, yeah. So my hero is a guy named Bunny Huang. Bunny is... he's well known for. Do you guys remember a product called Chumby?
Doesn't ring a bell for me.
It's like I don't know what it is.
It's this little like alarm clock kind of thing that sat on your nightstand.
Yeah.
Like it was like apps before the iPhone had apps. It was like 6 months. They had an app store before the iPhone did, like by 6 months. So Bunny was the hardware lead on Chumby, and Chumby was like one of the first big open source hardware projects. And he's one of our advisors. And the guy is like so smart, like unbelievably smart. You guys should actually have him on the show. So he's basically the godfather of open source hardware. He also wrote a book called, I don't know if I'll get the title right, but like Reverse Engineering the Xbox, where he literally walks through the process of reverse engineering an Xbox. He, since leaving Chumby, he advises a lot of hardware startups like us. He launched a product called Novena, which is an open source laptop that has like a FPGA. It's like got all sorts of crazy stuff in it. He recently did a talk on reverse engineering a 3G baseband so that you could take these like really cheap chips that you can find in China and use that are like cellular chips and use them for like basically. Like without, like you can basically build up the same baseband and not pay like massive licensing fees to them, or they probably won't let you do it anyway. But like just basically build it as rebuild it open source. And so he's an epic guy, and we ask him questions like, we say, oh, we're trying to figure out how to like get good RF performance on the Wi-Fi chip. Like, can you give us some advice? And he always sends us an email that says, well, I'm not an expert in this, but. And then there's this like 3-page response with every detail that you could possibly need to solve the problem, right? So it's like, I hope that I can be as knowledgeable as that one day, and also be as willing to teach other people and to help other people succeed as he is. He writes a great blog, Bunny's blog, and he's a huge mentor of mine.
So your hero is the founder of Chumby?
I don't actually know if he was the founder.
The maker?
The hardware lead at Chumby.
Okay. Cool. We'll try and find that link. If not, we'll work with you to get a link on that, put in the show notes for anybody who wants to follow up on that.
For sure.
Next question we'd like to ask is more or less, I think you might have answered a little bit during the call, but if you were speaking to the world of open source to a degree, what's a call to arms to some of the projects that are open source for you? How can people step in and get involved? Where are the most immediate needs today for you? Yeah.
So for us, like, our firmware libraries are the area where we'd love to have more people participating. Firmware is unique. It's different. It's C and C++. It's low level stuff. But what we're trying to do is make doing low level embedded development easier by taking all of the nasty low level bits and providing that layer of abstraction. And so we'd love help. So github.com/spark/firmware is our main firmware repo. And would love help from anyone who's interested in participating.
And I guess if you weren't doing what you're doing today, like hardware, software, what would you be doing? If you weren't doing X, which is today what you're doing, what would you be doing?
That's a good question. I don't know. It's hard to imagine doing anything different now. I like being an entrepreneur. I like running a company. I like making new things. I think if I weren't doing this, I'd still want to make something. I like hardware. I like gadgets. That's what got me into this in the first place. So if Spark disappeared overnight and I had to do something again, I'd want to start another hardware startup and like build something else. And maybe it would be a consumer product, which is where we started, and it didn't pan out for us. But I would try that again and find something like, to your point earlier, like Internet of Things is super gimmicky, and it doesn't have to be. Like, I think that, I'll give you one. Okay, here's one thing that I think somebody should build. And if I weren't doing Spark, this is what I would build. I want a 2-factor authentication safe. I want a safe that has a code, just like every safe does. And I type in the code, and I want that safe to send me a text message with a second code. And then I type that code in also, using the same 2-factor authentication principles that we use on all these web services with physical security. That's my, if I weren't doing Spark, I would love somebody. That idea is for free. If anybody wants to make that, we'll give you dev boards and tools to get started.
So if someone steals your safe or tries to break into it, they got to have your phone too.
Yeah, they have to have your password, but also they have to have your phone, just like, the same way you'd use that for security for a web service. So I'm waiting for somebody to build that.
2FAsafe.com.
Yeah.
Kickstarter that thing.
Oh, yeah.
That's an awesome one. And I guess the last cool question we have, and this one is sometimes fun because it could be your own stuff, or it could be something that you hack on that's not your stuff. But what's on your open source radar? What are projects that if you had a weekend and you weren't potentially hacking on Spark, what would you hack on? What would you play with?
That's a good question. So, despite the fact that we're talking all about hardware, I'm actually more of I'm really a front end guy. I do a lot of our web design. And so a lot of the stuff that I'm involved with is, from a tech perspective, is on the front end web development. And so I've been playing around, especially the last couple of weeks, with using we were building Express apps and doing a lot of stuff. I think that we were originally using Jekyll for some things, some static sites, Ruby library, and then switched over to doing stuff in Node. And there's some a project called Metalsmith that I think comes from segment.com. That's sort of a JavaScript version of Jekyll that we were playing around with, and I think it's awesome. I love tool chain stuff, working, playing with Gulp and projects like Metalsmith. I love developer tools, so things that are making it easier for other people to do other things. So I'd love to be participating in projects like those.
Well, Zach, it's definitely been fun having you on the call today. I know we can learn a lot from you, even though you may not say you're an expert in everything, like your mentor or hero says. You seem to have quite the expertise in this Internet of Things, software, hardware space that you're operating in. For the listeners, if they want to catch up with you, what's the best way to reach out, via Twitter, GitHub? What's some of the common social URLs you share for people to get in touch with you?
Yeah, so on Twitter, I'm Supalla, ZSUPALLA, and on GitHub, I'm ZSUP, ZSUP. And also we have forums for Spark that we love very much, community.spark.io, and my username there is just Zach, ZACH. So all those places, always happy to chat, and happy to help if in particular if people are building stuff and they need some advice. Always happy to offer some help.
Good deal. We'll make sure we link up those profiles and places you mentioned in our show notes. So if you're a listener, head to the show notes for this show, which is actually thechangelog.com/150, because this is episode 150.
Congrats.
Yeah, thank you. It's been an adventure, that's for sure. And speaking of adventures, we have awesome sponsors that make this adventure possible. CodeShip, Top Talent, DigitalOcean. Love those guys. They're so awesome to us. They've supported us to make this show possible, and we're just so thankful for all the ways that they support not only us but also the community themselves. So those people, awesome, just awesome. We do have another show coming up. Episode 151 is featuring Steve Klabnik and Yehuda Katz talking about Rust. Jared, are you excited about that call?
You know I am, man.
You know it?
Yeah,
What? You got the show notes ready already?
They're ready already.
They're ready already.
In my head. We'll be ready.
We've been dying for this show, so I hope everyone tunes in. Episode 151 again. Steve Klabnik, Yehuda Katz, talking about Rust. Can't wait for that show, but until we get there, let's say goodbye for now. So goodbye, everybody.
Bye.